Okay, grade 9, these are 3 questions that we had for your Chapter 6 review on linear relations. And I know some of you are having difficulty because, quite frankly, the last 2 weeks we haven't had a whole lot of consistency with our time. We've had a lot of, well, either a storm day or parent-teacher interview days or Tosh tour days or assembly days. It seems like we can't really get a whole bunch of traction here when we're together as a whole. I know I was out for 2 days myself personally, so it's a little tough. But anyway, we'll get through this. So Chapter 6 on linear relations is no different than your grade 7 chapter on linear relations or your grade 8 chapter on linear relations. There are a few variations with decimal coefficients and negative coefficients that probably are the only differences between the two chapters. But generally speaking, what you learned in grade 7 and 8 is probably what you're learning still in grade 9. So we have 3 questions. The first question here gives you an equation of x divided by -4 plus 1 will equal the y value, and it says to graph it. The second one gives you a table of values and asks you to graph and give the equation. And the third one gives you the graph and asks you for the equation. So in all 3 questions, what you're given is one piece of information, either an equation, a table of values, or a graph. Now, when you're given one of those pieces of information, you should be able to give me the other 2. So in the first question, you're given an equation. There it is there. X divided by -4 plus 1 equals 1. Now, it asks you to graph it. So before you graph it, every graph, if you're going to graph something, you need to have a table of values with a set of ordered pairs. You need to have a whole bunch of ordered pairs that you can plot into a straight line on a graph in order to be able to graph it. You can't just take an equation and graph it right at the back. So the first thing we're going to do is we're going to label our 2 parts to our table of values as x and y. Now, because there are no values given for x or y, we're going to make up values. Now, usually you can go 0, 1, 2, and 3. And that is a standard way to do it. Give 0, 1, 2, and 3, or just 1, 2, and 3, it doesn't matter. We're going to go 0, 1, 2, and 3 for the x values. And by randomly assigning those values into our table of values, we could then substitute each of those into our equation. So I can take that x that's here, and I can erase it. And I can put 0 as my first x value, and I can simplify that. So 0 divided by -4 is still going to be 0. And 0 plus 1 would be 1. So when I simplify that left-hand side, it's going to become 1, which means the y value when x is 0 is going to be 1. Now the same thing happens when I change this x value, and instead of putting 0, I'm going to put 1 this time. So now x is 1, all right? So we have the 1 value. So 1 divided by -4 is -0.25, and -0.25 plus 1 is going to be positive 0.75. And that's what the y value is going to be. So that whole left-hand side, when I substitute 1 for the x value, I end up getting the left-hand side simplifies to be 0.75, which means my y value is 0.75. Now, since I know that's linear, I'm probably going to guess this is going to be 0.5 and this is going to be 0.25. But just for poops and giggles, we'll substitute 2 in here for our third value. 2 divided by -4 is -0.5, and -0.5 plus 1 would be a positive half, which is true. And same thing when I put a 3 in there, and so on and so forth. So 3 will be -75 cents plus $1 is a positive quarter. So in the equation, x divided by -4 plus 1, I've now created this table of values that shows 4 points on the line in this graph. So that makes it nice and easy because if I think about it, I'm going to put 1, 2, 3, and 4, and 0. There's 0 on my x. And since my y values are all positive, I'm going to put, and it ranges from 0.25 to 1, I'm going to make each of these lines worth 0.25. So this is going to be 0.25, this is going to be 0.5, this is going to be 0.75, 1, 1.25, and 1.50. Now, how did I know to do that? Well, I had to look at the range of values in my y column, and I had to figure out that, you know what, they are going up by quarters, so I better put my size here as being 0.25. Right, now I have that done. I'm going to label this as x. I'm going to label this axis as y. And I'm going to plot the first one. 0, 1 is going to be right there. There's my first point. 0 on the x, 1 on the y is, actually it's a grade 5 concept. When you learned about Cartesian planes, I think you probably learned it in grade 5 and 6. I know in grade 7 for sure we did the Cartesian plane. And then when x is 1, y is going to be 0.75. So that ordered pair, sorry, right here is 0, 1. This ordered pair here is going to be right there, and it's going to be 1, 0.75 on the y. This one is going to be 2 on the x and 0.5 on the y. And this one here is going to be 3. That's really not a great line, is it? I better put this up just a little bit. And that one just up a little bit. It's going to be 3 on the x and 0.25 on the y. So when I connect those dots, I end up with my line, and that is the graph that you needed to create for the first one. Okay. The second question, this time it gives you a table of values. There is no equation this time. It gives you 3 values, 3 ordered pairs. It gives you 4 on the x, negative 12 on the y, 0 on the x, 0 on the y, and negative 4 and 12. So the first thing I can do is graph it. So my range on my x goes from, actually, you know what? I better change this. Hang on. I better change this whole thing. So I'm going to take this and delete it. Actually, I'm not going to delete it. I'm going to move it over. I'm going to move this up here. Because I realize that the values I need for both, I need a full Cartesian plane because I have negative values in the x and negative values in the y. So I'm going to go on my y. I see that it goes up by 12s. So I'm going to make these units, you know what, I think I can still make them 2. So 2, 4, 6, 8, 10, 12. I'm going to go up by 2s. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. All right, so now I have my range that I need for the y. I need everything from negative 12 down here up to positive 12. And I just defined each of those ticks as being units of 2. And then on my x-axis, I need to go between 4 on the positive. So there's 4 to 4 on the negative. All right, so there's a positive 4 on my x-axis and a negative 4 on my x-axis. And there's my y-axis. So when I graph these 3 points, the first one is 4, negative 12. So 4 is here. Right, 4 is here. And 4, negative 12 would be right down, I can't really approximate it. This is 4, negative 12 on the y. 0, 0 is the easy one because that's the origin. You learned that in grade 7. And then the last point, I better move this here. The last point you have is negative 4 on the y, which is, or on the x, which is right here, and positive 12, so it's going to be up here somewhere. Okay, and hopefully if I did this well enough, I can connect those 3 dots. That's not too bad. With a line that shows all of it. Now, the second part to that, that's kind of the easy part, is the graphing, because it's really just a grade 7 question. The second hardest part is the equation that matches this line. What is this line called? What is the slope of the line, and what is the y-intercept, if you want to think of it from grade 10? So we realize that if we put this down, this blank template, leaving space for a coefficient and leaving space for a constant, we could show the relationship between x and y by manipulating x to the point where you get the value of y. Because right now, 4 does not equal negative 12, so I have to do something to the x value to get it to equal the y. So the first thing I do is I look for my coefficient. This is going up by 12 each time. And this is going up by 4 each, or sorry, down by 4. So down by 4 each time. So negative 4. And the coefficient of your equation is determined by the difference of your y divided by the difference of your x. So if I look at that y, it's a 12, a positive 12, goes up by 12 each time. And the difference in the x is going down by 4. So 12 divided by negative 4 is negative 3. That means that is the coefficient for your x. Okay, so I put a negative 3 there. Now, I need to determine if there is a constant. All right? So the first thing I'm going to do is I'm going to take my partial equation, leaving space for my constant. I'm going to substitute any pair. I'm going to substitute this one in. So negative 3, and the x value in that pair I circled is 4. The y value is negative 12. And when I work that out, negative 3 times 4 is negative 12. So there isn't a constant necessary in here to balance the two sides, because already they are. Which means, if I ungroup this for a second, hang on a second, let's see if I can do this. Ungroup. Oh, that's not what I want. I want this one. Ungroup. That means that there's no constant, which means the equation that defines the line is negative 3 times the x value will always give you the y. And therefore, I can write it right on the line itself. Every point on that line will be taking the x value and multiplying it by negative 3, and you will get the corresponding y value by doing so. And the last question gives you a graph and it just says, give me the equation. So right here, the first thing you got to know is each of these steps is going up by 0.5. And you could see that it starts at 0 and automatically starts at 12. So it skipped everything from 0, 0.51, 1.52. So in order to show that we skipped a whole bunch of stuff, you break it up like that with a little squishy line thing, okay? And that means we omitted part of that axis. So the first point, this one right here, is 1 on the x and 12 on the y. This is 2 on the x and 12.5 on the y. This is 3 on the x and 13 on the y. And this one is 4 on the x and 13.5. So I'm going to put that on my table. So the first thing I do is make the table. So I have 1 and 12. I have 2 and 12.5. 3 and 13. And 4 and 13.5. So once we have that, we know we're looking for the equation. So again, from a table of values, I have to put my x and y coordinates down like that. And I need to determine what is my coefficient and what is my constant. The first one you're going to check for is your coefficient. This one right here. And we get that, again, by the difference in the y divided by the difference in the x. So the difference in the y, as we go down here, it goes up by a half. This goes up by 1. So 0.5 divided by 1 is simply 0.5 because anything divided by 1 is itself. So that means my coefficient will be 0.5. So I'm going to put the coefficient in front of it. Now I could also express this if I wanted to. I could express it like this because it's the same thing, half of x or half of x. All right? So I'm going to take that partial equation. I'm going to substitute any ordered pair I want. I'm just going to take the first one. I'm going to substitute it in. So 0.5, the x value in that pair I circled is 1. The y value is 12. And here's a great example of how both sides don't equal. Because 0.5 times 1 is 0.5. And in order to get the two sides to balance, I have to add 11.5. So I'm going to add 11.5. And once I do so, I see that the equation that matches that table of values in that line is actually half of x plus 11.5 equals y. Or, I can put it right on the line, half of x plus 11.5 equals y. If I want to do it a different way, half of x plus 11.5 equals y.